This one took me a minute. I had some issues just to try and figure out what we have going on here. So we've got a car, and we have a force pushing it off to the right. We'll say that's force net, which that's what we're trying to find. But there's also, he's coming from rest, so you've got the force of static friction. And of course, you've got his weight down, and he's on flat ground, so he's got his normal force, and his normal force is up. So weight equals normal force. Also, you've got a trick is that it's going from 0 to 80 miles per hour. So the first thing I'm going to probably do is I'm going to say 80 miles per 1 hour. We do some dimensional analysis. That's an MI. There's 1 mile, and I know these in my head. There's 1,609 meters in a mile. Miles cancel, and 1 hour is 3,600 seconds. Figure out what that number is. You'll need that. Okay, but the trick on this one is to try to figure out what is the acceleration, right? So, but the F net, okay, you have to overcome. So if you want to have maximum speed, you have to overcome, as they say, they have to overcome the static friction because it sits at a rest. And that's the big issue that's solving the problem. So if for all intents and purposes, the F net equals the force of static friction. And then you can solve for A, and F net, that's MA. A is what you want to solve for. And then the force of static friction is mu static times, in this just case, mg. Might notice here the m's cancel. So, and you're going to plug in the mu is static friction. Hint, hint, it's super easy. And then you can solve for A. Once you know A, you're just going to use one of the kinematics equations. You want to find time. V2 equals V1 plus AT. From here, you're going to know what V2 is. V1 is 0. A, you're going to find from here, right? And you're solving for T.